Let us now complete the lecture number 3 of the mathematics course. We start with the subject of the derivative, and we learn the basic rule of this subject. After that, in the second lecture, we explain how can we find the derivative of the exponential function and the logarithmic function. Now we will complete in this lecture, lecture number 3, about the derivative of trigonometric functions. So that let me explain something that d by dx for sine u is equal to cosine u multiplied by the derivative of the angle, which is u, with respect to x. Also, d by dx for cosine u will be minus sine u du by dx. We need only these two formula to develop the derivative of the tan, tan and cotan trigonometric function. Also, in order to develop a relation for sec and cosec, only we need to save these two rules. So that let us explain the derivative of tan. The derivative of tan d by dx of tan u is nothing but sec square u multiplied by du by dx. This is the derivative. This is the derivative of the angle, which is u. So that let us explain or prove this formula. This is the left hand side, and this is the right hand side. So that let us prove that left hand side equal to this right hand side. We start by writing the left hand side, which is d by dx for tan u equal to, we know that tan can be written like this, sine u divided by cosine u. After that, we can find the derivative of sine divided by cosine, because this is nothing but function divided by function, and we know from the first lecture what is the law for division form. Let me just remind you that d by dx for u divided by v is equal to, I will write it here, this is the denominator, v square, and here I will write v multiplied by du by dx minus u dv by dx. So that let us apply this law to this. We can write that this will be cosine square u, and here I can write cosine u, which is the denominator, multiplied by the derivative of the denominator, which is sine u, and the derivative of sine u is cosine u, so that cosine u multiplied by du by dx minus sine u multiplied by the derivative of cosine is this, minus sine, so that this minus will be here, so that this will be positive, sine u du by dx. After that, I will do the following mathematical simplification, which is here I will write cosine square u. Cosine u multiplied by cosine u will be cosine square u du by dx plus sine square u du by dx. Now I can take du by dx as a common, so that this will be cosine square u plus sine square u du by dx divided by cosine square u. Now we know that one of the most important and famous trigonometric relation, which is this. Let me just remind you, as you take it in the secondary school, sine square theta plus cosine square theta is 1. So that cosine square u plus sine square u can be replaced by 1, divided by cosine square u multiplied by du by dx. Also, let me just remind you that 1 over sine u is cosec u, and 1 over cosine u is sec u. So that 1 over cosine square u will be, according to this, will be sec square u multiplied by du by dx. So that in this way we prove that d by dx for tan u is equal to sec square u multiplied by the derivative of the angle du by dx. Similarly, and using the same technique actually, we can prove that d by dx for cot u is equal to minus cosec square u du by dx using the same techniques. Let me just prove it. This is the left hand side, d by dx for cot u, d by dx. We know that cotan can be written like this, cosine u divided by sine u. Now we will apply the rule of function division derivative, which is the denominator will be squared. Here we'll write the denominator, which is sine u, multiplied by the derivative of the numerator, which is cosine u, is minus sine u du with respect to x, okay, minus the denominator, which is cosine u, multiplied by the derivative of sine u, which is cosine u du by dx. After that, we can write this expression like this, minus sine square u, sine u multiplied by sine u, du by dx, minus cosine u multiplied by cosine u can be written like this, divided by sine square u. Now I will take minus and du by dx as a common, so that this will be sine square u plus cosine square u, I hope that this is clear, divided by sine square u. Now again, sine square u plus cosine square u is actually 1 divided by sine square u, and I will write du by dx here, so that again, as I mentioned for you before just a few minutes, that 1 over sine u is cosec u, so that 1 over sine u is minus cosec square u multiplied by the derivative of the angle, which is du by dx. In this way we prove that the derivative of cotan function with respect to x is nothing but minus cosec square u multiplied by du by dx. Beside that, we have also another two important relations in the subject of the trigonometric function derivative, which is d by dx for sec u equal to sec u tan u multiplied by du by dx. Also we have d by dx for cosec u is nothing but minus cosec u dot cotan u du by dx. This actually can be derived easily, so that let us explain how can we derive this. I will start by this. Let us prove that d by dx for sec u is equal to sec u dot tan u multiplied by du by dx. Now, as I mentioned before just a few seconds, that d by dx, 1 over cosine u represent sec u. This is actually taken from the secondary school in the subject of mathematics, so that this is the left hand side and this is the right hand side, so that I can take the left hand side d by dx for sec u equal to d by dx. Now I will replace CKU by, it is 1 over cosine u. Now after that I can do the following. All I have to do is that actually this is nothing but this function divided by this function. Actually this is number and this is function, so that I can derive it using the similar techniques, which is this. 1 over cosine u can be derived like this. This is denominator will be squared, cosine square u. After that I can write the denominator, cosine u, multiply by the derivative of numerator, which is 1, and 1 is a constant, so that its derivative is 0, minus 1 multiplied by the derivative of the denominator, which is cosine u, and we know the derivative of cosine u. Just before a few minutes I write for you the derivative of cosine u is minus sine u multiplied by the derivative of the angle, which is u, with respect to x. Now this will be 0, so that here I have this minus will multiply by this minus sign, so that it will be positive sine u divided by cosine square u du by dx. Now we can write this like this. We know that sine u divided by cosine square u can be written something like this: 1 over cosine u multiplied by sine u divided by cosine u du by dx. Now 1 over cosine u, as I mentioned before here, is nothing but CKU, so that I will write CKU. And sine u divided by cosine u is tan u multiplied by du by dx. In this way we prove that d by dx for CKU is equal to CKU tan u multiplied by du by dx. We can use actually the same procedure to prove that d by dx, let me prove it, d by dx for cotan u is equal to, sorry, not for tan, d by dx for cosec u is equal to minus cosec u cotan u du by dx. All we have to do is to take the left hand side separately and analyze it separately. D by dx for cosec u, this can be written like this. Cosec u is actually nothing but 1 over sine u, so that 1 over sine u. After that, all I have to do is to find the derivative for this, so that this can be written like this: sine square u. Here I can write the denominator, which is sine u, multiplied by the derivative of the numerator, which is 1, which is 0, minus 1 multiplied by the derivative of the denominator, and derivative of sine u is nothing but cosine u multiplied by the derivative of the angle, which is u with respect to x. So that this term will be 0, and this can be written like this: minus cosine u divided by sine square u du by dx. Now I can write cosine u divided by sine square u like this. This will be 1 over sine u, and this will be cosine u. Sorry, it may be not clear. Cosine u divided by sine u multiplied by du by dx. Now again, 1 over sine u is actually cosec u, and cosine function divided by the sine function actually is cotan function, cotan u, multiplied by du by dx. In this way, we prove that the derivative of cosec u is nothing but minus cosec u multiplied by cotan u multiplied by the derivative of the angle, which is u. Now it can be seen that we have to know only the derivative of sine u, and cosine u, if we know this, which they are cosine u du by dx and minus sine u du by dx. If we know these, we can save them actually, then it is very possible and very easy to develop the derivative of the another trigonometric functions like tan u, cotan u, sec u function and cosec u, as illustrated just before a few minutes. Now let us take solved examples that cover the subject of trigonometric function derivative. Let me solve this example. For example, y equal to tan. The angle is 3x squared. So that this is my function, and I would like to find, of course, the first derivative, which is du by dx. This is the goal of the lecture, is to find du by dx for this function. Actually, in the subject of function, when we see any function, it is very important to keep in our mind that this function may be a constant, then the derivative of constant will be 0. This function may be actually u divided by v, which is function divided by function, or u multiplied by v, or u plus minus v. Actually, we illustrate how can we find the derivative for all these functions. So that, and also we should keep in our mind that u to the power n, this is actually very important. And now we can apply this rule to any function, trigonometric function, exponential or logarithmic function, or any function, so that we can find du by dx. Now let us find dy by dx for tan 3x squared. We know that d by dx for tan u, as I mentioned before just a few minutes, is equal to sec square u du by dx. In this way, it is possible to find the derivative for tan 3x squared like this. I can write this y equal to tan 3x squared. Then dy with respect to x equal to, according to this function, is sec square u, and u here actually this is represent u. Okay, so that u is equal to 3x squared. In this way, this will be sec squared for 3x multiplied by the derivative of u with respect to x. Then du by dx will be 3 multiplied by 2x to the power 2 minus 1 multiplied by the derivative of x with respect to x, it will be 1, so that this will be 6x to the power 1. In this way, I can write it here, 6x. Now I can just prepare it, 6x sec squared 3x. This is dy by dx for this function, for tan 3x squared. Let us take another example. For example, let us find dy by dx for cosec x plus cotan x squared to the power 2. Now, this is actually nothing but y equal to u to the power n. Then it is possible to find the derivative for a function like this, which is dy by dx equal to, this will be 2 multiplied by cosec x plus cotan x to the power 2 minus 1 is 1, multiplied by the derivative of this function. And now we know the derivative of cosec u, as I mentioned before. The derivative of cosec u is minus, okay, minus cosec x plus multiplied by cotan x multiplied by the derivative of the angle. Since the angle is x, then its derivative with respect to x, it will be 1. Okay, multiplied by this will be for the first function. Okay, plus, let me just write it here, plus the derivative of cot u, and derivative of cot u actually is minus cosec square u, which is x here, multiplied by d by dx for is 1. So that this can be prepared, actually, this can be prepared to be something like this. 2 cosec x plus cot x multiplied by minus cosec x cot x minus cosec square x. Now I can take as a common parameter, which is cosec here, and this is cosec square, so that it is possible to write it like this: 2 cosec x plus cot x multiplied by cosec, and this is minus sign can be taken as a common parameter, which is minus will be written here, and this will be cosec x, and then I have just cot x plus cosec x. Now you can see that this is cosec x plus cotan x, and this is cot x plus cosec x. Then it is possible to write this is minus 2, and this cosec x, this will be written like this: cosec x plus cotan x to the power 2, because this is similar, so that it will be 2, sorry. So that in this way we find that the answer will be minus 2 cosec x multiplied by cosec x plus cotan x to the power 2. I hope that this example is clear. Now let us complete with another example. For example, let us take or find the derivative y equal to or 2 sine x over 2 minus x cosine x over 2. Now, since this is a function, then dy by dx will be the derivative of the first function. The derivative of sine actually is cosine, so that this will be cosine u, sorry, I mistake here, dy by dx 2 sine x over 2, because here u is x over t, multiplied by the derivative of the angle. The derivative of x divided by 2 is nothing but 1 over 2 minus. Now, this is actually nothing but this function, the first function multiplied by the second function, so that let me open the bracket because here is a sign. And this way, the first function, which is x, multiplied by the derivative of the second function. The derivative of cosine is actually minus, so that I will write here minus sine x over 2 multiplied by the derivative of the angle, which is just 1 over 2, plus the second function, cosine x over 2 multiplied by the derivative of the first function, which is 1 only. Now all we have to do is a small simplification, which is dy by dx equal to this 2 can be cancelled with this, and this way I have sine x over 2 minus now let me do this minus x over 2 sine x over 2 plus cosine x over 2. Now after that, actually, we can find that this can be written like this: sine x over 2 minus, multiplied by this minus will be positive, x over 2 sine x over 2 minus cosine x over 2. After mathematical simplification, we will get that this answer will be x over 2 sine x over 2. Okay, or sorry, I mistake here. This is sine x over 2, then its derivative will be cosine x over 2. Okay, cosine x over 2 x over 2. So that this cosine of x over 2, I hope that you know what I do. This is 2 sine x over 2. Then in order to find the derivative, we know that the derivative of sine is cosine x over 2. Actually, this is illustrated just before a few minutes. Then after that we have cosine x over 2 plus x over 2 sine x over 2 minus cosine x over 2. We can cancel this with this till we get x over 2 sine x over 2, because this term will be cancelled with the third term till we get the derivative of this function is x over 2 sine x over 2. Now let us take another example, which is x plus tan xy equal to 0. Let us illustrate the implicit differentiation of this example, which is the derivative of x is 1 plus the derivative of tan, the tan function, its derivative is sec square xy multiplied by the derivative of the angle. Now this is the angle, then its derivative will be the first function, this is function multiplied by this function, and we should keep in our mind that we derive corresponding to x, then it will be the first function, this is the first function, this is the second function, so that this will be something like this. The first function x, the derivative of this second function is dy by dx, plus the second function, which is y, multiplied by the derivative of x with respect to x is 1. In this way, equal to 0. Now, this will be 1 plus sec square xy multiplied by x dy by dx plus y equal to 0. Then I can transfer this term to another side, so that or I can transfer 1, so that it will be sec square xy multiplied by x dy by dx plus y equal to minus 1. Then I want to find dy by dx. Then it is possible to write it like this. I will distribute this on each term, so that I have equal sec square xy multiplied by x multiplied by dy by dx plus y sec square xy equal to minus 1. Then I will make the following. The term that contain dy by dx will be on the left hand side, and the term that doesn't contain dy by dx will be transferred so that, to the right hand side, so that this doesn't contain dy by dx, so that it will be transferred, and its positive sign will be negative sec square xy, and this will be dy by dx x sec square xy. Now it is possible to write this like this: dy by dx equal to minus the negative sign can be taken as a common, 1 plus y sec square xy divided by x sec square xy. In this way we find the derivative dy by dx using the implicit techniques. And in this way also we can do the following more simplification till we get that this answer dy by dx is equal to let me explain it here, equal to minus this negative sign. This will be 1 over sec square is cosine, so that after that I have cosine square xy plus y divided by x, because all I have to do is that I transfer this function to the denominator, because sec 1 over sec is nothing but cosine, so that this will be cosine cosine square. After that I distribute it. Let me just illustrate it. We reach for dy by dx equal to minus 1 plus y sec square xy divided by x sec square xy. After that, we know that sec square is 1 over, let me write it, 1 over sec u is equal to cosine u. In this way, I can write it cosine square xy multiplied by this 1 plus y sec square xy. Now, I will distribute the cosine on this, so that this will be minus cosine square xy plus y multiplied by cosine square xy multiplied by sec square xy divided by x. Further simplification will be 10 to cosine square xy plus y. We know that this can be cancelled with this, because cosine is 1 over sec square xy multiplied by sec square xy divided by x. In this way, we find the result will be cosine square xy plus y divided by x. This is dy by dx. This is actually nothing but further simplification for the problem. So that in this lecture we illustrate how can we find the derivative of the trigonometric function. I hope it is clear. In the next lecture, I will illustrate the following topic, which is very important. We learn how can we find the derivative of the inverse trigonometric function, which is very important subject. And also the hyperbolic function, we will explain the derivative of the hyperbolic function in full details, so that the inverse function and hyperbolic function is very important. After that, we will explain the derivative of inverse hyperbolic function. I hope that the next lecture, which is lecture number 4, will be enough that cover so that it can cover the topic of the inverse trigonometric function and hyperbolic function, as well as the inverse of the hyperbolic function. After that, numerous problems that cover the subject of derivative will be solved, so that lecture 5, as I hope, will be about example that cover the subject of the derivative. So that in this way we complete the lecture number 4, which is about the derivative of the trigonometric function. We explain it in full details. Thank you very much.